So good morning, everybody. Everybody can hear me okay? Good morning. I just want to make sure Jeff can hear me. It's pretty important. But hey, I'm Scott Wilkin, if you don't already know me. I'm the acting deputy director here at NCSA. And it's really wonderful to welcome you to the first of our several NCSA 30th anniversary events that are happening this week. But the most important thing is it is my great pleasure to introduce my friend and colleague, Donna, Dr. Donna Cox. Donna's I'm going to read this one part. So Donna's a nationally renowned scientific visualization and art expert who has spent her career inventing new ways to enable discovery and bring science to the public. Donna has been at NCSA since almost its inception in 1985, and was key in positioning NCSA as a leader in scientific visualization. So if you're thinking about 1985, so Donna must have been, what, 2 or 3 when you started it? Is that right? So very, very early. So really got into visualization very early. But Donna's work has been featured in many movies and documentaries, including the award-winning Tree of Life, and which was directed by Terrence Malick, if I said his name right, and the dome shows such as the recent IMAX film, which hopefully most of you went and saw, A Beautiful Planet, narrated by Jennifer Lawrence. Donna is the University of Illinois' first Michael Aiken Chair, Director of the Advanced Visualization Lab at NCSA, and Director of the Illinois Emerging Digital Research and Education in Arts Media Institute, also known as, and thankfully known as eDream, and Professor in the School of Art and Design at the College of Fine and Applied Arts. Donna has made and prepared for us what I think is really cool and insightful and entertaining talk about the unofficial history of visualization. Please join me in welcoming Donna to the stage, and let's hear it for Donna.
Well, thank you very much. It's a pleasure to be here. I want to thank people who've gotten me old slides. I'm going to show some historical slides and historical video. Barbara Jewett and Steve Dunsing has helped me, but in particular, Jeff Carpenter and I have tried to get into the archives and scan slides and video, and some of these are going to be seen, and even more, tomorrow night at the Accord, where Larry Smar, Ed Seidel, and myself will do another unofficial history of things at NCSA starting at 7 o'clock. I do call this the unofficial history of visualization. It's highlights. I'm going to show a lot of pictures. I'm going to try to be I hope I don't forget somebody. I'm sure that I have forgotten somebody. I've been here a long time. Some of these images are from, I couldn't get everything together because we just don't have images. For example, I couldn't find some early images of Ed Seidel here at the center when he looked 14 years old and was a postdoc. But I have selected a few because I think there are some things that we created in scientific visualization, in televisualization, in certain areas of virtual reality. The NCSA and the University of Illinois created a paradigm shift. And so part of what I'm doing here is I'm co-editing a book on the history of women in new media arts, perspectives, and innovative collaboration. Excuse me. And this book has not even come out. It's going to be printed by the University of Illinois next year. It's already been celebrated at the School of the Art Institute. What we did was interview 24 women and have women writing as well as part of the book, and we do a history of the Midwest since World War II and before, and the impact that women in the Midwest have had upon technology and sort of the untold stories through an oral history. A lot of these people you will probably recognize. This is Maxine Brown, Carolina Cruz, Colleen Bushell, Nan Goggin, Sally Rosenthal with the famous picture of her in virtual reality. Judy Malloy wrote the first history of women in technology, and on. Brenda Laurel wrote Computers as Theater. Jane Veeder and Donna Plepes is still working with Maxine Brown at the University of Illinois at the Electronic Visualization Theater, Visualization Lab. So this book has not only been an oral history that we've been working on for years, but we have a very large introduction which sets the stage and the emergence of NCSA and the University of Illinois and some key historical but unnoted historical points, and where women and technology and the arts were involved in some of the early days. Now, if you can see, this is Tom DeFonte here, who in 1975 went to the University of Illinois in Chicago. These are all the students from the lab at Electronic Visualization Lab. This is Dan Sandine. And Tom DeFonte graduated, was the first computer science graduate from Ohio State University. Here he is with hair down to longer than mine, his shoulders. And this is Dan Sandine, his cohort. Dan was actually in the art department up at UIC, and Tom was in what he was inventing was the computer science department there. And they had a collaboration of bringing artists and scientists together. Now, the state of visualization in those days, the state of computer graphics, was so fundamental that analog, this Sandine image processor, he invented to create computer images, and it was later merged with a computer through Tom DeFonte. So early on in the 70s, they started getting together as a collaboration between art and engineering. Here's Larry Smarr about the time that he wrote The Supercomputer Famine in American Universities and started on what is now well known as the Black Proposal around circa 1982. And this was also the state of graphics and scientific visualization around that time. It was plotter printouts, in this case of an astrophysical jet. The computer graphics industry was barely able to do a rendered image. This image by Nelson Max, published on the cover of Computer Graphics in 1983, was the state of the art. It took many days to render a single image, and it shows for the first time some of the smooth surfaces that were just being realized at Siggraph. That's the ACM Special Interest Group in Graphics Conference. And so that was the key conference, especially at that time, and it was growing at an astronomical rate. I was at the University of Wisconsin. Here I am creating art. At that time, you had to put a camera in front of a big old screen. This is one of them back here. This is Pat Hanrahan in 1983. He introduced me to computer graphics. I heard about this guy on campus, and I was an artist doing traditional art, and I realized that I wanted to work with a computer. And he had all the knowledge about computers. Pat has since he left, he was in the zoology department, I was in the art department. We collaborated for a while. I learned how to program by taking his old code and working with it on computers. He left and first went to some early pioneering computer graphics areas, including then eventually went to Pixar, became a professor at Princeton, and also a professor now at Stanford. He is the co-founder of Tableau, which is one of the largest and most successful information visualization packages out there. And I can say that I now actually know a billionaire. Pat is a really nice guy, but he's been incredibly successful in the computer graphics arena. This is 1985. Again, what do you see here? This is an image that was created by Craig Upson, a scientist who was working in Digital Productions, which was a production house that did commercials. And a lot of them in that day did commercials like the sexy robot. It took very large teams of people to pull off this particular image. But he was a scientist that was not happy there. And he was working, John Whitney, as in John Whitney Sr.'s son, who is very famous in the arts for the computer imaging that he did with music and did original films, John Whitney Sr. Well, his son, with Gary Demos, started this computer graphics house to do commercials. And at the time, Maxine Brown was working there, and she got to know these people that were using a supercomputer to make graphics. And it just so happened that Larry Smarr could not get any graphics done, so he went to Digital Productions to try to get an image of an astrophysical jet. He met Craig Upson at that particular time. And then there was an early Siggraph conference, and I introduced Larry to a number of people at Siggraph, and I'll talk in just a little bit about what evolved from all that. But this was state of the art, and the point from this image is that Hollywood had better computer graphics than anything a scientist could get their hands on. Now here's an early image near the opening of the NCSA. So there was a grant written, there was a competition, there were 5 original supercomputing centers. Larry is the founding director of this one, but there were 4 others, and we were all in startup mode. I had just come here as an assistant professor, and Smarr and many other people, Bob Wilhelmsen, scientists, John Anderson was part of that. John Anderson is currently working at Pixar. So there were scientists that were in here working at the supercomputing center, but there was this play that was going back and forth between Hollywood people coming to NCSA and scientists going to Hollywood. So during that period of time, they constructed the Cray 1. I dug up these old photos. Jeff Carpenter, here's a balloon that somebody had stuck to a picture of Larry Smarr. It says, "God, I hope the damn thing works." And that was this construction that he's talking about. And people were making jokes, but it was a lot of effort. The Academic Computing Building, ACB, was being torn apart. It had been the astronomy building. And at the time, we were all in the mode of talking about the center and what it could be. This is some of the first, look at these old monitors. This is Barbara Mahalas, Michael Norman. We were doing poster sessions around monitors like this, and talking about the possibilities of what visualization could be and do. This is me. If you see, that's an old slide projector that's a combination of a monitor. Strangely enough, this leads to a bigger point with a collaboration with Kodak that made all the world's slide projectors at that time. So here is like the first year, about 1985, 86. Here's Bob Wilhelmsen in an interview with media about the beginning of the center. Well, once the Cray was built, it was a photo opportunity for everybody. And it was colorful. Everybody had to have their picture in front of it. And dignitaries and people from all over the world came to sit on the Cray and get their picture taken, including in 1988, Al Gore was in the same room. That means you went over to Springfield, went into the basement of Cab, and go down into or up into, not the basement of Cab, but into the bowels of Cab. And that is where the supercomputer resided behind glass walls. And this, by the way, this connection with Al Gore will resurface when we get to 1989. That's my beauty shot in 1988, done by an artist, Kurt Fishback. But this is the reality of how most people worked with these large computers in frigid rooms with monitors that give you cataracts. And we worked very hard in those days to get graphics on the screen. So basically resurrecting, here's the first collaboration that I had was with Michael Norman about 1985-86 on this jet. And I had taken an old software that I had used in Wisconsin to make art and brought the first color editor to NCSA. And here is Mike Norman, Karl-Heinz Winkler, Jim Bottom, and Larry Smarr, some of the early photos from that era. And then a student that I started working with, Ray Adasic, I'll talk about that collaboration in a little bit. Tom DeFonte, Maxine Brown, I don't know this gentleman. Lauren Hare eventually got a hold of Al Gore and interviews him for a big televisualization video, and Larry Smarr. And this is in the basement of Cab. The first Renaissance team was with George Francis, who is just retired, a mathematical topologist, and Ray Adasic. And we created this Venus series, which was this topological surface that actually animated and became like characters in a story. So this was some of the first graphics that came out of NCSA. It was mathematics, but the method of bringing together an artist, a scientist, and a computer scientist, that idea took hold. And here's Dan Sandine again on the right with shorter hair, and Ellen Sandur, who's a co-author of the current historical book, myself and George Francis up at a Chicago art gallery in 1986, showing the scholograms. So Ellen and Dan collaborated. She was from the Art Institute of Chicago, and Dan collaborated on making these scholograms, which are these lenticular screens. And you can see one in room 1005. The work got patented, but this was the first digital scologram, which was the Venus series. Now this is at Siggraph 1987, and this is one of the first art shows. The art show did not begin at Siggraph until about 1980, and that was started by Copper Gilleth, who is part of the book. And these are the scholograms in the art show, and this is Tom DeFonte, Ray Adasic, Dan Sandine, Larry Smarr, me, and Ellen. And we had a great time in those days, but it was more that we were shifting the entire culture of Siggraph to pay more attention to scientific visualization. We also had some pretty great industrial partners that invested a lot of money because they just wanted to figure out what supercomputing was. And so Rich Elson and Larry Ray spent a lot of time here full time, and I collaborated with Rich Elson to design one of the first rendered computer graphics glyphs with 2 color maps at that time. It had never been done before with computer graphics. And we published a paper that got on the cover of Simulation in 1988, and it was being written, had been written in 1987. So that was the first time that there had been the term glyphs used in this way with 3-dimensional computer graphics. And what hit the news was that Kodak could actually patent a glyph as a process. So that was new, and said in the press that they had saved billions of dollars by being able to see plastic being injected into Kodak slide projectors, and that's what that study was about. But what was really happening here is that there was a new language that was evolving. It was happening in Australia, it was happening in England. The graphics had come to a fruition to the point to where you could, in a very hard way, attach to the background the data. And Bob Haber was a key in this, and Greenberg had a whole laboratory that was doing something like this, but not quite the same. There was a lot of focus on the Siggraph realism, trying to get computer graphics to look real, And it took some effort to really encourage the community to move forward with computer graphics being used to represent data. So this was a new empowerment to have data being used to be represented. In general, there was this motive that was there, and it was like teaching people how to read data, to look at it and read it. And it was creating, from these glyphs, like hieroglyphics, you could represent or represent the data in different ways. Now, this is still back in 1986, and so that conference on the West Coast in Eugene, Oregon, the applications of the leading edge, it was a Pacific Northwest Computer Graphics Conference. They still were not really doing data-driven scientific visualization, but pioneers in the graphics industry were starting to come together with people in science. Eventually, Maxine left Digital Productions. She came out to be at the Electronic Visualization Lab at UIC, and that is when, before that, I had introduced Maxine to Larry Smart at Siggraph, and at that Siggraph in 1987, lots of people were there, or this was shown in 1986 in the Electronic Theater at Siggraph, but this work is a historic work. It was written as an NSF publication in visualization and scientific computing. It was written by Bruce McCormick, Tom DeFonte, and Maxine Brown. But what this did, and it had a lot of input from NCSA, the cover image, it was Bob Haber, a lot of the pioneers that were working on computer visualizing data gave input, but it laid out the challenges that would in fact be the challenges for the next 20 years in visualization. In the same year, 1987, there is this cover of computer graphics, and it's more of the cultural view of what was taking place with scientific visualization. Visualization was starting to be treated as an old Paleolithic Ice Age relic that was used in Paleolithic times to control and predict the future in culture. so was this new medium of supercomputer graphics and supercomputer scientific visualization. At the time, NCSA was on so many covers. If you go into Ed Seidel's office, you will see cover images after cover images of black holes. There were, it was as if we got in print everywhere with this new, turning billions of numbers into pictures. And so during that 1986 Siggraph, this woman right here was hired. Her name is Nancy St. John. She was a top-rated producer of film and advertisements in Hollywood. She had been at Digital Productions. Her partner, Craig Upson, came. And essentially, this Hollywood group started to get formed around visualization, but it was a kind of polished production quality visualization that required a team. Here's Matt Arrett. We see Stefan Fangmeyer here, Jeff Yost. Jeff Yost is currently still working in research at Industrial Light and Magic. He left NCSA and went to Industrial Light and Magic. This is the back of Colleen Bushell, I think. Stefan Fangmeyer worked on the original 1989 thunderstorm visualization, and he eventually left, went to Hollywood, to Industrial Light and Magic, and worked on Twister. So those balls that you see that are in the movie Twister, Dorothy, were actually represented as data originally at NCSA. So there was a connection between people coming from Hollywood, working on scientific visualization, and then leaving and going back to Hollywood. But this is the basement of CAB, and in 1986 in the computing applications building. This was 1987, the beginning of the Beckman Institute, and it was very clear that NCSA was growing very quickly during that period of time, and a lot of it had to do with we needed more space to get people out of the basement of CAB and things like that to be able to have space. So we had a lab that was established among 2 floors on the Beckman Institute. That's when NCSA could fit into that area. And here's a class taught in the Renaissance Experimental Lab. This guy back here eventually went on, Chris Landreth, to get an Academy Award. This is Fred Daub. Some of the early visualization team, Ingrid Kallick was taking classes there. We had George Francis teaching classes, Donald Hearn. Lots of faculty from campus came over to this room and taught through NCSA interdisciplinary courses in computer graphics. And that particular lab was donated by Silicon Graphics co-founder Jim Clark, who later, many years later, came back and ended up forming Netscape from the Mosaic group. So that lab was actually established from Jim Clark. So by 1988 at Siggraph, we were basically taking over the world. We had a research group that was doing research in scientific visualization. That group was called Rivers. It was led by Bob Haber. I was in that group, so was Mike Norman. And it was, Rivers stood for Research and Interactive Visualization Environments for Science, I think. Bob's here, he can correct me over pizza. But anyway, that group was really concerned about the research cutting edge of graphics. The other visualization group had formed. They had talks that were being driven by faculty from campus talking about representation, interpretation of the visuals. That was an ongoing talk series. I believe Alan Craig was part of that, and the group would come together and had interesting speakers about the psychology of scientific visualization. Altogether, we put together for 1988 a demo reel that showed a sample of 1988, all the visualization that is coming out of the center. And Randall, could you please set the lights low? Thank you. And just leave them there, please. And so this is a sampler from 1988 showing the breadth of the different kinds of visualizations that were primarily being done by the visualization group. Fractals, that's Mike Norman and Jet. That had gotten in the year before. This is a very highly competitive electronic theater. That year there was probably upward of 32,000 people at the conference. This was work being done with Amico. Here's the Venus with George Francis, Ray Dasik. This is chemistry that was being studied. I do not remember if this was Klaus Schulten at the time. Yes, it was Klaus Schulten. This is work that was being visualized of Klaus. So at some point, the Siggraph said enough of demo reels. They wouldn't accept any more demo reels. But at the time, there was nobody in the scientific visualization Siggraph community, which was very large, that matched what was happening here at NCSA. This was work that I did with the relativity group and more chemistry. So we created a paradigm shift in one of the most influential conferences at the time. That was pre the 1989 thunderstorm. This was very, very early data. This is the 1989 thunderstorm, which is still a classic and had a very large circulation and a large team that really took this apart. So again, I just want to impress upon you how fundamental computer graphics was in those days. It did take a lot of programming to do anything. You did not have off-the-shelf tools. This visualization of the smog in LA was used by the scientists to change policy around the world. You knew that if you went to Los Angeles, you were going to be hit by a great big yellow ball right in the head. Climate change, we got some of the first data from NCAR to visualize it on climate change. And of course, we had a very large visualization team as well. And we were all, this is the visualization, the first data-driven visualization of the internet. So on the covers, again, of everything. Now I want to talk about something that's very special. You've heard people talk. I mean, you have to realize in 1988, 89, there was no internet, no cell phone, no internet. So we wanted to do science by satellite. And so science by satellite, this idea, I credit Bob Haber, Dave McNabb, Robert Ellis from Sun Microsystems. I mean, this idea of trying to go from Champaign, Illinois, NCSA, with the Cray 2 and visualizations here on the Alliant, video switcher uplink to AT&T downlink video switcher to a projection on the stage, Boston Museum at Siggraph. And Lauren Hare was also videotaped Al Gore to introduce what we were going to do on stage. Here's Mike Norman, here's Larry, Bob Haber, me, and we had Al Gore talking about the information superhighway, which of course did not exist in 1989, but it was in the works at NCSA. The NSFNet was being born even during this time. And the idea was to have Bob Wilhelmsen, who was back here in Urbana, over next to Cab, and here is the famous 1989 thunderstorm in the jet. We were all going to get out there, and Haber was leading this effort with the Rivers Project. But it was the most expensive demo, I think, in the history of Siggraph. That satellite link alone, they estimated, was $250,000 for the hour or so that we were able to show how science would be done in the future. So this was, looking back, this was the future. So I want to play this just a little bit.
Bob, are you there? Yes, I am, Larry.
You can boost the audio if you can.
Hey, this is Bob Wilhelmsen. He's the research scientist. Bob is the research scientist that was the group leader on the 3D thunderstorm that you saw in the film and video show last night. What's really interesting is, Bob, over the last 5 years that you and I have been working on this with a lot of other people, just to see the transformation of the way that we do science in this country. I mean, as a result of the National Science Foundation initiative, the 5 supercomputer centers now have over 10,000 users in say 200 universities that are linking from their desktop computers across the NSFNet to these supercomputer facilities like you see here in our machine room. Okay, so we're going to use the same sort of technology you see on the evening news where you have a remote link, and we're going to use that to beam the images across in video. What do you say?
Now, this was pretty unusual to have visualization coupled at all to anything that remotely looked like a network. In fact, I remember seeing a demo of Mosaic, and a scientist asked, why would you ever want to have an image attached to an email? That's how far we weren't thinking ahead in terms of how this worked, or I should say some people weren't. But this is pretty interesting because this was a whole hour. We don't have time for it all, but I do want to play this section to give you the feel of the kind of interactive visualization that was going on and trying to communicate that you could do it over the internet in the future. Where Bob Haber just explains all of the technology and how the Alliance was rendering images and how these were being uploaded. Now, I have to tell you that the night before, nothing worked. Absolutely nothing worked. We all spent all night long at Denny's, at a coffee shop, trying to have plan B if we got out there on stage with hundreds of people for 2 shows in the Boston Museum, and nothing was working. How were we going to pull this off? But the day of, it did work, and if you want to ask Bob Haber, he just showed up, and that was a surprise, so he'll be here for the pizza,
Bob,
I hope.
are you there?
So that was just unbelievable that we were participating, but tying visualization into it. That 1989 also marked a big change in mainstream. National Geographic up to that point had never published an image that wasn't a photograph. This was the first issue that there were images that were not photography. This is the sexy robot, which Nancy St. John had been a producer on that. It won awards in the Super Bowl that year. But all of this and scientific visualization had its own section. And it had to do with images that were coming out of NCSA. The following year, in 1989, we were establishing the IEEE Visualization Conference in 1990. The first conference was in San Francisco in a Hilton hotel, very small and intimate. But it was the beginning of that paradigm shift forever, because Siggraph was never going to contain all of what we could do with scientific visualization. There were too many areas of research, and IEEE Viz was taking that over. I had just come, when we did the IEEE Viz first conference, I had just come from being at EDUCOM, which is now called EDUCAUSE. I was the first female to give a keynote for EDUCOM, and this was 1990, and I was a keynote speaker with Steve Jobs, Jimmy Carter, Robert Allen. That was the first time I talked about Renaissance teens to thousands of people, and Jimmy Carter even came by and wanted to know more, since he had a son that was an engineer and a daughter that was an artist. How do you make these teams work? It was a marker in my life, and ended up talking about the work that was going on in the Renaissance Experimental Lab with EDUCOM, wrote an article about the work that was coming out of there. Robin Barger was one of the students. I mentioned Chris Landreth, moved on and got an Academy Award with short feature films later. And here is a slide, and you can probably find yourself in it. But by 1990, this was the entire NCSA staff in the Beckman. Here's people like Rada, Dave Curtis, Mike Smith. There's Bob Wilhelmsen. If I miss you, I apologize. Here is Scott Lathrop with brown hair. And there is a very thin, I think, John Towns. I mean, everybody got into the picture. Here is Beth, I think. And anyway, I've got a couple of these that I discovered in my office if anybody is interested. It was really a community like the community today that we have at NCSA. And here's the visualization group. Now, Bill and Alan went on to write a book on virtual reality. Colleen Bushell went on to work on the first visual browser. This guy left, and he did the DreamWorks logo with the kid in the fishing pond for DreamWorks. Mark Bayuk is now working for the company that made Ice Age. All of these people, Polly Baker has gone on to Indiana University, Matt Ehret. I don't know where some of the people have gone, but this, and here in the middle, is Deanna Spivey holding the sign about visualization. The team was sitting on the stairs of the computing applications building, and we felt like at the time that in 1992 we were really changing the world. But visualization permeated everything. I mean, you couldn't do anything without it just saying, okay, we're going to do a visual browser. So Colleen Bushell worked with Mark Andreessen. She's not well recognized for the work that she did on the first Mosaic for laying out the whole conceptualization of how you use the internet and what is a browser and making it visual. She had a very important contribution that's being recognized in the book. And of course, internet was sweeping the nation. But little known was Ping Fu, who was the person who hired Mark Andreessen on an REU grant during a summer, and she was the one who also brought Colleen Bushell in to work on Mosaic. And Ping has since left. She's been on the cover of Fortune. She started her own business in Chapel Hill. Now, about the same time, the Electronic Visualization Lab up in University of Illinois, Chicago, here's Dan again. He always liked his hats. And Maxine and Tom DeFonte, Donna Plepes, were getting it together. This was, again, introducing really high-end visualization to the supercomputing community at that time. And the graphics were so, there were just not enough visualization to go around. You had to have it with, your browser. You had to have it, we needed an NSFNet image, because here's a 1992 report. They only had this crazy diagram. They came to me, NSF did, and said, we need something that is more than a diagram. Can you do an image? So Bob Patterson and I, in the REL with a bunch of students, started coding by hand the lines that went to the internet, and eventually created this video, which has been used around the world to help increase networking to countries that had no networking.
Since 1986,
Boost the audio, if
the
you
National
would.
Science Foundation Backbone Network has expanded and upgraded to provide an information superhighway linking researchers, educators, and industry across the United States. The Testbed Network has grown exponentially to connect more than 2,000 client networks. This data visualization spanning a 2-year period represents a rapid growth of traffic that exceeds tens of billions of bytes per day.
Which is small
This
now,
dendritic
right?
infrastructure
Tiny.
is evolving into the National Research and Education Network. It is intended to revolutionize the ability of educators, academics, and industry to carry out collaborative activities regardless of the distance. International connections reflect an information flow across continents, bringing people together, connecting a world of ideas.
So visualization brought together with story and a documentary, Doug Quick did the narration on that, had impact. And that's what's happening today even in New York City with the Godin project. We started coupling the visualizations in documentaries. Off-the-shelf tools started to incorporate a lot of the techniques that we had already invented here. Siggraph Vroom was the first time that virtual reality had gotten to Siggraph in this way, the Electronic Visualization Lab with the cave, and we cloned the cave here. Here's George Francis. It was sold out. They had lines, and NCSA and NSF was helping to sponsor that event. Here's Bob in the cave. Everybody then started to have a beauty shot in the cave as well. Yes, we all had our beauty shots and collaborated. We were very close in collaborating on visualization with the Electronic Visualization Lab, because we regularly worked on cave applications and visualization applications. Virtual Director, which I've talked about in the past, is being used even today. We developed it with EVL, Marcus Tiebo, during the making of Cosmic Voyage, which was then a year later, nominated for Academy Award. It was the first time data had ever gotten into an IMAX film. That is, visualizations in an IMAX film in 1987, or 97. So from where I was coming from, I was going off in this other direction, but there was plenty of research going on here at the center with visualization, data, and virtual reality. One of the things that never had been done before was Cyberfest, which was the birth of HAL. And we, NCSA, was very much involved with that. And next year, there is a Cyberfest 30-year anniversary, which we will be involved with again. And during that time, it was a celebration of the birth of HAL. The movie 2001 Space Odyssey was played in the Virginia Theater, and then NCSA did Machine Child at the Krannert Center for the Performing Arts. Now, this was introduced by Roger Ebert. Roger Ebert introduced 2001 Space Odyssey over at the Virginia. At the time, there was plaster dropping off from the ceiling, but he got this pristine copy of the movie. It was historic. It led to the refurbishing of the Virginia Theater that you have today. And NCSA was involved. This was the first time that virtual reality in a live big performance had been included. It was the Cyber Gala at the Krannert Center for the Performing Arts. And the setup here, I don't even have time to tell you how complex this was, but there were 3 projection screens on stage. There's In-Suk Choi, who's one of the creators, and Robin Barger. And it's all being done to the Blue Danube, like in the 2001 movie. Now, note that they're cinching her up to virtually, this is just part of an hour-long performance, but this is the part where she goes, she's so nervous, oh, I didn't really need to plug that in there anyway. And she is going to virtually, everything that was on stage was being controlled by computers underneath the stage to demonstrate this futuristic world that had been envisioned by Arthur C. Clarke. So what she's doing here is reenacting one of the scenes of 2001 Space Odyssey by touching the toe. And this is virtually, her feet are driving this thing by all these computers and rotating this computer graphics object virtually for the performance. In the interest of time, so that led to Ebertfest. Cyberfest and the Cyber Gala led and kicked off, and the very next year, Roger Ebert said, well, this was fun. Let's do that again. So Ebertfest was born the following year, and panels and campus engagement came out of that. So I'm going to jump forward because I gave you a very in-depth early history. I want to just touch upon later stuff and anytime and point to things that are happening as part of Pygmalion. So the Alliance 98, some of you were here, we took over the assembly hall and put all kinds of virtual reality equipment and demonstrated all kinds of things out on the floor. And here's an early, and we had talks. This was in the REL, and here's an early picture of Bill Gropp and Andy Johnson and Jason Lee from EVL. Here's the back of Dan Sandine. We had a MRSA desk. Here's Jay Alameda. Ken Bishop for University of Kansas. We had Glenn Wheelis, who was in a wheelchair, and the way he could fly was through virtual reality. We had invented avatars that could communicate and remotely communicate.
Can you see me?
Yep. How you doing, Glenn?
Hi, Glenn.
Hi, Glenn.
Alliance researchers have created a virtual reality application called CVD that enables real-time data exploration using the Cave, ImmersiDesk, or Powerwall. One of the components of CVD is Virtual Director, a software framework that allows a user to interactively construct, record, and preview scientific visualizations using voice and gesture input.
So, could you turn the
The
audio
other component
down
of CVD is
one?
K5D, a configurable application that lets
Go
scientists
ahead and turn
visualize
it
and
further
interact
down.
with multidimensional numerical
So these are
data from
different
atmospheric,
virtual
oceanographic, and other
devices all
similar
communicating
domains.
with one another
It's nice
over a
I can see you
common
laying down
data
a few
set.
frames.
There's Stuart Levy with a beard.
Is it looking pretty good?
Yeah, it is.
And our representations of our avatars are our unique locations in that three-dimensional space. And we had Caterpillar was doing research with virtual reality. And just keep the audio down on this. What she says is that the NCSA, over here, the BBC flew over. There was collaborations with other places like the Museum of Natural History. That was in 2000. And then by iGrid over in Amsterdam in 2003, there was a three-way collaboration over visualizations between the Stephen Hawking Lab, the San Diego Supercomputing Center with Mike Norman, and Amsterdam. And so the work just kept getting more complex. And a lot of these stories have been captured, and the early knowledge around virtual reality was written in an early book by Bill Sherman and Alan Craig, and captured a lot of the stories, not only from the center, but where things that were going on elsewhere. The fundamental research. Again, NCSA had kicked off something. It was creating this kind of new way of thinking about the inclusion of visualization as part of a virtual reality experience. Well, I'm going to jump forward a lot because we're running out of time. And I can say right now that just as in any new field, such as physics or visualization, the early problems are the easiest problems to solve. The more mature, the longer a discipline is around, the harder the problems are to solve. And so we are at a peak when it comes to trying to, with scientific visualization, deal with massive amounts of data, like what comes out of blue waters. And we also have several teams here at the center that are doing complementary work. This is the NCSA Data Analysis and Visualization team with Rob Cisneros, Dave Bach, and Mark Van Moor. And Mark is focusing more and more on information visualization, but they deal with some of these really tough issues that Blue Waters has posed to us through the massiveness of the data and the challenges there. Here is one of their pieces with LEORF data. Oh, sorry, slow beginning. It's going to move. I know it's going to move. There it is. Okay. So this is a silent, but this is a huge, shows the structure of the grid. And so we have come a long way since the 1989 thunderstorm. This is a whole different level of ingesting and rendering the amount of data that we have to deal with today. It is estimated that most of the data that exists right now in the world has been produced over the last few years. We are experiencing a kind of data deluge. And here we have new tools, new ways of dealing with it, but we still are crunched and have new challenges to deal with. And my advanced visualization team that is under a culture and society theme, we have, in fact, worked on a lot of different stereo and documentaries and have been funded through the Cadence. We have completed many movies, IMAX movies, feature film, digital dome shows, finished the IMAX, The Birth of Planet Earth. And what is different about it now than in the early days, it's much bigger. We're reaching more and more and more people with large-scale museum shows, but we're having impact now on the content, on the script, what stories are being told. And that has changed. So as part of the Pygmalion, you can go out and see one of these documentaries at the Sterkel Planetarium. And I'm going to just show you the trailer. But this movie that you can go see at Sterkel on Tuesday night was shown to a part of the Senate on May 25th of this year to help educate the legislators about a topic in science and using visualization as a support mechanism for telling the story. And that's what these documentaries are about. And we had impact through the Cadence Research Grant to measure how people understand the film and understand the visualizations.
A fury is building on the surface of the sun. Jets of super hot gas. Rising waves of fire. The most violent explosions in our solar system. Journey into our star. To explore its inner workings. And experience the power of solar superstorms.
You can go see the entire show as part of the Pygmalion Festival at the Sterkel Planetarium, 7:30 on Tuesday, September 20th. An AVL team will be there to discuss their contributions. We're also working on things like mapping with the DES LSST, doing work toward another documentary that explains the vast scope of coverage that's being of the sky, the all sky by DES LSST. It's huge, and we're trying to complete this documentary that will help explain the vastness and the intense work that's going on here at the center. And also the work done by More Blue Waters simulations. This is Brian O'Shea's work with Michael Norman, and it is being wrapped in and making a connection between computational and observational science in this documentary, which is a story that really needs to be told. We have continued collaborations. We're working with students and Cypress Institute on Oculus Rift and current technologies in VR. And we have continued our collaborations with the Krannert Center and artists to do virtual reality on stage. You can bring up the audio. And this was done in 2012, but for the sesquicentennial of the university, we're going to be working on another piece in which the technology interactively will be incorporated into a very artistic presentation. That's in the works. And then finally, we still collaborate, and it really gets down to when we used to talk about the Cray being like a rock, and everybody, it was like stone soup, and everybody would come and want to give money to it or build stuff around it. But having the supercomputer was one part. A lot of it is about the networking, about the storage, and of course about the visualization. And the GLIP map is currently in the process of being updated by Maxine Brown and Bob Patterson. So in closing, and I'm sorry this went a little long, But in closing, I just want to say that we have a moment here now. At the time when NCSA was established, we had a moment. There was the newness of supercomputing in academia, but that's not news anymore. But we have a moment here to better understand and to deal with this plethora of data that we are facing. It's a huge challenge. Just think about it. Most of the data we create and we cannot understand. Visualization will be one of the tools to help us with that. And there's going to be supercomputers. There's going to be an entire culture around that. And also, we need to have more of the humanists and artists involved. These are interdisciplinary issues because data is not sacred. Data is what it is, and our algorithms have to be examined from a cultural point of view. And all of these images, going back historically into present day, are about interpretation and how we interpret that data. There is a lot of work to be done, and we can seize the moment here for our future, and it will incorporate visualization, I guarantee it. And with that, I will close, and I'm sorry I kept you so long. We have pizza to go to.
Donna, I can't believe we didn't go for like 3 more hours. That was so fantastic.
So much I
It was
left
so
out.
fantastic.
I left out a
I want
bunch
to
of
thank
stuff.
you. I want to thank you also for just pointing out the incredible history of pioneering innovation that has come out of NCSA and from you and from your team. It's just inspiring. And I think my job as NCSA director is to make sure that we continue another 30 years of pioneering innovation as well. It's just fantastic, and I really appreciate it. I've also, I don't know, is that your laptop there?
It is.
I just sent you an email with an image that, I don't know if you can show it there, but it shows how far we've come. So I dug up an image during Donna's talk of an old visualization that Larry Smarr made for black hole embedding diagrams. Before you could do 3D visualization, he had to use paper mache. And I want to show you, I've sent you a picture of one of Larry's early scientific visualizations that should be in your email.
Oh boy, I can't.
Maybe you can't get it, okay.
I can't
But-
get to it right now, but let me try to do this.
But just imagine, you had to actually build physical models of these things, which is actually what Larry was doing before you could do any of this computer visualization. So it's amazing how far we've come.
Yes, I think the first thunderstorm was in fact done with pipe cleaners and cotton, that there was a conceptualization before the visualization. I've got to get.
So that's the state of scientific visualization before Donna. It's amazing.
And that's made out of what?
Paper mache. Larry cut out
mache.
pieces of paper with the right triangle edge lengths. He had done that sort of wireframe thing and said, okay, I got to see what this really looks like. And so he made a paper model of it before you could actually do a computer model of it.
Oh my gosh.
Yeah.
Oh, fantastic. Well, I just want to reiterate that this is a great community, and NCSA continues to be my favorite place, my community, and I appreciate, and sorry if I forgot to credit someone, because a lot of you helped me pull this together. My team, Amanda Lombardo, has been terrific, and Scott and Ed, and so let's go eat.